Hi everyone, today we're going to learn about solving problems involving linear systems. The idea of solving a problem with a linear system or a point of intersection on a graph is not new to us. It's something that we've done before. Today what we're going to do is look at a problem about Euclid's electronics. So Nahid works at Euclid's Electronics and she's paid at a salary of $200 per week plus a commission of 5% of her sales for the week. The equation P equals 0.05s plus 200 represents Nahid's pay for the week, where P represents her week's pay and S represents her total sales. So she gets more money based on the fact that she makes more sales. So this is her incentive to want to work hard when she's working at the store. So we're going to use the equation to calculate how much she sold if her total pay was $290. They're giving us pay, or P in this case, so we're going to substitute that value of 290 in the place of P of our equation, and then we'll have to work to solve it. As we know, in order to solve an equation, we want to isolate the variable. So we'll need to bring the 200 across the equal sign, and it'll turn negative when it goes there. And then we'll simplify. 290 take away 200 will give us 90, and that will be equal to 0.05s. In order to isolate S, to find out the amount of sales she made, we'll need to divide both sides by 0.05. This will give us $1,800. So we can conclude that if Nahid was paid $290 in a week, that means she made $1,800 worth of sales. And we can check this on our graph. If we go to right around 290 on our vertical axis or our dependent axis and go across until we touch the line, we'll see that the line does in fact touch at about $1,800 worth of sales. Nahid is offered a job at Ferment's Footwear. At this other store, the base pay for the salary will be $100 per week, but she'll get 10% of commission on all sales. So it's a lower base salary, but a higher commission rate. So the graph shows the pay versus the sales of this new job. We want to figure out what the equation for this situation will be. We can use the equation model dependent variable equals rate of change times independent variable plus initial value for this because it's representing a straight line. The initial value will be 100 because that is the base salary, and the rate of change will be 0.10. This is the commission rate, the rate of change in this case. So our equation could be P equals 0.10s plus 100, where P is the amount of pay and S is the amount of sales that she would make in a week. Now we can use this new equation to determine how much sales she would have made in a week in order to earn $290 at this new job. So we will again sub in the P for 290 because that's the pay that we are being asked to determine the sales for. And then we'll solve this equation to isolate S. So in this case, we're going to bring 100 across the equal sign, turning it negative. And that will mean that there is $190 is equal to 0.10s. And again, we're going to divide both sides by 0.10 so that we can isolate the variable. And this will give us $1,900 in sales that Nahid would have needed to make in order to earn $290 at the new job. We can again verify this on our graph by looking at where 290 is on the vertical axis and moving across until we hit the line. And we can see once again that this happens right around $1,900. So based on these two job options for Nahid needs to have some help determining which job she should keep. She decides to look at these two equations as a system of equations. And then she can create a graph to compare the two equations at the same time. You can see the graph now has both equations on it. The point where the two lines cross each other is called the point of intersection, or the solution for the system. On this graph, you can see that the point of intersection occurs for a total value of sales of $2,000 and a week's pay of $300. What these coordinates mean is that for Nahid to earn $300 at either of the jobs, she needs to sell $2,000 worth of product. If Nahid usually makes $1,500 worth of sales per week, she is before the point of intersection. And at this point, before the intersection, it looks as though the Euclid's electronics is the better option for her. At this point, she would earn more money for less sales. Now, the next question is asking, how much money in sales would Nahid need to make the other job have better pay? So in Ferment's footwear, you can see that it's not until after $2,000 worth of sales that the line is higher on the graph. So if she were to make any more than $2,000 worth of sales in any given week, the Ferment's footwear would be a better option for her. So the graph helps Nahid to determine which is a better job because she can use it to decide, based on her typical weekly sales, which job will she earn more money at. And this again is going to depend on how many sales she typically makes each week. The last question asks, in what other circumstances could finding the point of intersection be useful in solving a problem for real life? There are lots of different situations where you can use the point of intersection to help you solve a real life problem. Anytime you have a situation that can be represented with a linear equation, and then you want to compare it to another similar situation, a point of intersection can be found to be very useful. So this might be something like, a base cost of a pizza is $8 and then it's $2 per topping versus another company which might charge $5 for the base cost of the pizza, but then only charge, say, 75 cents per topping. So the number of toppings that you are going to have on your pizza is going to determine which of the companies is a better option for you because you want to buy the pizza that will be the least amount of money.